Here we have the square root of 49 x squared y to the fifth z to the sixth. In this case we have a radical, and there's understood to be a 2 here for square root. Any other radical would have a root number in this spot. So, for example, if it was a 3, we'd be looking for a cube root. Okay, so since there's a 2 there, we're looking for pairs. In this case, we have a 49. 49 is a perfect square, so we really don't need to break it down with the factor tree. However, if you didn't recognize that 49 was a perfect square, we could break it down. What numbers go into 49? We have 7 times 7. Since we have a pair of 7s, we know that we can take the square root of 49 perfectly, and that pair goes to the outside of the root. So I have 7. And then we have x squared. So you can recognize that we need pairs, or you can break it down into x times x. Since we have a pair of x's, x would also move to the outside. Okay. Same thing with y to the fifth. I have y to the fifth. How many pairs can we get out of y to the fifth? So we have y, 5 times. So I have a pair, I have another pair, then I have this one left over that does not have a pair. So I have 2 y's on the outside, so I have y squared. And then in my radical, I have a y remaining. And then z to the sixth, instead of breaking it down like this, I recognize that there's 3 pairs in z to the sixth. So since I have 3 pairs, I have z to the third power. Now, since I had an even root to start with, I'm going to put absolute values around each of my variables. Okay. So my answer is 7 times the absolute value of x, y squared, z cubed, to the square root of y.